Good day to you again, boys and girls. Thank you for coming back. Okay, I'm back too. Today, another different topic. Let us touch on electricity. This is a very interesting topic, very simple. I've got a very simple way to help you understand this aspect of electricity. And the section that I'm trying to tackle this morning is this. V equals to IR. You are very familiar with it. So we will go straight into it. Now again, I would like to encourage you. You make just even one change in the way you study, it can create a big improvement in your results. Another reminder is what we have covered before. Part of output revision, the most important aspect is rehearsal. In other words, you have to tackle past year examination questions. And this is exactly what I'm going to do now. Let us look at this past year examination question which says this. Diagram 25 shows three similar bulbs connected in series to a battery and an emitter. And the question says this. What will happen to the emitter reading and the brightness of the bulbs when another similar bulb is added to the circuit? Choose A, B, C or D. And remember the last time we said we need to go back to the formula page. And with all the formulae given, we need to know what are some of the formulae that we can use in this particular question. Alright, let us go and tackle it step by step now in this question. And that is the question given to us. Let us just look at the diagram. The first question says, what happens to the emitter, the reading in the emitter? Alright, let us then highlight the emitter. And it says, what happens when one bulb is added to it? So, let's say that on the left-hand side, this is episode 1 before we add the bulb on. In the second one, that is the one when we add the bulb. Alright, I'll use a different color so you can see it. I add another bulb here. Alright, so I call this L1, L2, light bulb 3, light bulb 4. This is light bulb 1, light bulb 2, light bulb 3. So we are talking about the emitter reading. Now please tell me, emitter reading, what is the quantity? What do we mean by emitter reading? Very good. You say current, okay? So we know that we are actually dealing with the current. We want to calculate what is the current in the first diagram and what is the current in the second diagram. Alright, we call this the first diagram. And this is the current in the second diagram. Basically, we want to compare. How do we solve a problem like this when no values are given? May I suggest that you just write down the values. A good value would be, alright, let's call this 60 volts. Okay, that is my choice. You can choose anything. And let's say this is 5 ohms. Because each bulb, as you know, it has a resistance. So we have 5 ohms each. 5 ohms. Let us write down everything here. 5 ohms. Okay. So right now, look at circuit number 1. What is I1? As you know, we are looking at V equals to IR. I'll just write it down again. V equals to IR. V equals to IR. So what is the value of I? Simple mathematics. I equals to V over R. Now I'm going to write down 1 in every case. Because we are talking about the first episode on the left-hand side of the screen. So what is the voltage given to us? Okay, you can tell me. Simple. It is 60 volts. R1. R1 is the effective resistance between the 2 points. And let us say that the 2 points are, let's call it X and Y. I can call this point X. I can call this point Y. So what is the effective resistance across XY? Okay, I'm sure you can tell me because it is the three resistances or the three resistors, the three bulbs, they are in series. So you know that it is straightforward, very simple. 5 ohms plus 5 ohms plus 5 ohms. Alright, so we will just write down 15 ohms. Alright, so let us carry on. And what is the answer here? I have 60 volts divided by 15 ohms. Sorry, I just write down straight away the answer. I have got 4 amperes. Now that is our first episode. Let us carry on with the next episode now on the right hand side. Okay, now I am adding on one more bulb, L4. So what is my I2? So looking at the left side, I'm sure you can tell me that it is equals to V2 over, it is V2 divided by R2, where R2 is the effective resistance between X and Y. Again, we must have X and Y, the same 2 points in the circuit. Very simple mathematics again. What is V2? Okay, good. 60 volts divided by R2. R2 is the effective resistance from X to Y. Alright? So it is 5 plus 5 plus 5 plus 5. I have got 20 ohms. Alright? And what do I get? 3 amperes. That is I2. This is I1. So, on the left and on the right hand side, what has happened to the electric current? What has happened to the ammeter reading? Look at the answers again. Ammeter reading, it has, I'm sure you can tell me, yeah, decreased, isn't it? Okay, very good. So we know that the ammeter reading has decreased. We just write it down for good revision. Ammeter reading has decreased. Alright, that is the first part of the story. Now what about the second part? Brightness of the bulbs. Now I have got one very interesting way to show you the brightness of the bulbs. So over here, our story is what happened to the brightness of the bulbs when we add one more light bulb to the circuit. Alright, I add one more here. I can call this L4 again. L1, L2, L3, L4. This L1, L2, L3. Now, generally speaking, boys and girls, if you are given a circuit when there are no values, you pick values and put it. Any values, anything that is simple to use. So, I choose 60 volts, 60 volts. Alright? Now, I would like to explain this way. Remember that 1 volt is actually, can you give me another unit for 1 volt? Anybody? I see you smiling at the end there. Okay, we learned it before. 1 volt equals to 1 joule per coulomb. Alright, very good. 1 joule per coulomb. In other words, it talks about energy. Every 1 volt means 1 joule of energy given to drive 1 coulomb of charge around the circuit between one point to the other if we are talking about potential difference. So 60 volts. Okay, allow me to play a simple game with you. Alright. Interesting, isn't it? You see, physics is simple. I've told you, you don't believe me. Alright. So 60 volts, I'll use 60 ringgit. to represent 60 volts. 40, 50, 60. Clear? Alright. Now this particular person, he actually has 3 sons. L1, L2, L3. How many sons? 3 sons. Very good. 3 sons. And he wants to give or distribute 60 ringgit and let the 3 sons share. Because the 3 bulbs in series, basically they have to share the voltage. They have to share out the energy. Alright? So, what does each get? I'm sure you can tell me, isn't it? Okay, very simple. This is 20 ringgit. 20. Alright? And then another 20 ringgit here. Okay. And then another 20 ringgit here. Okay. So each of the bulbs, actually you have 20 volts or 20 joules per coulomb across it. If you would like a diagram for me to illustrate, it would go something like this. This is V1. This is V2. And this is V3. Alright? And you would know that V1 here is 20 volts. V2 equals to 20 volts. And V3 is also equals to 20 volts. So if you look at it, in diagram 1, or I should call it 3, in order not to confuse the first two, in diagram 3, you notice that you have 20 volts for each light bulb. It is like this. Each of the light bulbs has this much of energy. Okay, I call this the energy. Alright, I always do this in class. 20 joules of energy for every 1 coulomb. So 20 volts. Alright. Now, look at diagram 4 now. I call this diagram 4. What happens? I've got only 3 cups here. But now I add 1 light bulb. I think some of you waving at me. You say, Uncle, add another cup. Okay, magic show. Okay, alright. Add another cup. Now what is going to happen? This father is a very good father. Now he has 4 children. 1 was just born. So 4 children share the 60 ringgit. You have to share, right? Share the 60 ringgit in the same way as diagram 3. So each child will get how much? You can tell me, isn't it? You're experts with money. No problem. You will understand this. 15 ringgit. 15. Alright. 15. Okay. 15. Now, if you look at it from this point of view, it is very easy to understand what has happened here. Because each of the bulbs now in diagram number 4 on the right hand side, you would realize that how many volts there? I'll just write down. L1, how many volts across L1? You would know that it is 15 volts. What about this? 15 volts. What about this? 15 volts. And what about this? Another 15 volts. Okay? So by just looking at the point of energy per unit charge, you know that the brightness of the bulb, what would have happened? Only 15 volts. Just now was 20. So which one is brighter? On the left hand side or on the right hand side? Okay, you can tell me, isn't it? So, very simply, when you look at the 2 diagrams, you will know that over here, the brightness has decreased. So, the brightness here has decreased. Okay? So, what are the 2 things? Let us summarize. The first thing that we have discussed basically is making use of V equals to IR. And here also we understand that effective resistance in series, you just add up the individual resistances. And secondly, here we have actually studied how the potential difference is divided among the lamps that are placed in series, where I use a very simple method to help you see the point. So with this, I hope that the next time when you look at a question on electricity, you would be thinking about, not money, but you'll be thinking about simple concepts where you can even use money to understand it. So with that, I wish you all the best again in your revision in physics. And thank you very much. May God bless you.